Yo, Mr. Yuli. So this is our group. I'm Kidir.
I'm Arafat.
I'm Shafiq.
I'm Udin.
So from all the few projects that you have asked we all to choose, we have picked the car park project. Yeah, so our aim for this project is that our end product must have, there will be 6 lots. So when the car goes in, the LED will count down like from 6, then to 5, to 4, to 3, 1, and F which is equal to 0. Yeah, F is 0 and is equal to full. So yeah, we basically we do this all by referring to our previous lab sheets and consultation for our lecturer, our TSO. Yeah, we ask them a lot and they help us. Yeah, so okay, now we will talk to you about the steps.
Okay, hi sure. So I will be explaining to you about the steps for today. So these are the steps. First thing, we have to go to the file and create a VHDL code. As you can see, the VHDL code is already written. So all we have to do is compile this code, and if it's successful, we don't have to troubleshoot, but we have certain errors, so we have to troubleshoot, and it's already successful. So after that, we do the same for all the other three VHDL codes, which is VCD counter, 6 LED, and 7 segment VHDL codes. For each of it, we have to do this step for our project in order to do the block diagram. So we have to
Firstly, all no error.
yeah, but first thing first, we have to make sure that there is no error for all the VHDL codes. So at each VHDL code, we have to create at the coding create, then create symbols for current file, and then we have to close the project and open the next project. For this one is 771. The next one should be VCD counter. So after all of that is done, we will open block diagram, and then we will insert all the things inside. Okay, moving on to the next stage.
Okay, so after this, then we have to create the vector waveform, which is to our own reference to see whether the code is working. Yeah, so this is the vector waveform. Yeah. So this is the vector waveform. So like it's on our own reference so to see whether our code is working or not. Yeah, so after that, then is the schematic block diagram which we put from the 7 segment, kappa LED and BCD counter. So the debounce, just for you know, is to cancel noise. Okay, so after we have create all these block diagram from the previous VHDL, we have to assign the pin, planner for A1, A2 all the way, and uploaded it to the board. Okay, so now I pass to Udin to talk about the board.
Okay, so my name is Muhammad Nuruddin. So basically, this is the board. Okay, so after assigning the pins, we already wired it up. So total there will be 6 LEDs. 1, 2, 3, 4, 5, 6, and so basically this one is the in sensor. This one, the very last switch will be the reset button, and this one will be the clock, the second one, and the first one will be the out sensor. So basically, when the car park is empty, all the 6 LED will light up. Okay, so when a car went into the gantry, right, one of the LED will be turned off. Okay, So when the next car park when the next car came in, another lock is taken up, so another LED will be turned off. So when a car in the car park leaves the lot, the LED will light up. But unfortunately, our in sensor is not workable. Therefore, we couldn't show the 7 segment to you. Basically, currently the car park is empty with the number 6 here.
Am I?
Okay, now.
So I'm here to tell you about the code Archer. So yeah, just give us a moment. So this is the BCD counter. So there's our input will be here. We have created port and stuff. Okay, so our input will be the clock reset in sensor, out sensor, and then our output will be the 3 down. We are using 3 down to 0 because we need 8 bits in order to get 6. So there will be two empty space for us, because if you use 2 down to 0, it will only give us 4 bits, so which is not enough for us to use for the 6 LED. So we have used this as this one. So begin, if the reset equals to 0, then count signal will go to 6, where that means that there's 6 slots available. So as if falling edge clock, then if each sensor equals to 0, then count signal equals to 1. That means you'll minus 1. So from 6 you will go down. When a car enters in, you'll go down. This is what it means in this sentence. And same goes for here. When it's out sensor, when a car goes out of the car park, you'll increase by 1, going back to 6 if it was in 5. So yeah, so this is how the BCD works for us. So yeah, this is the car park LED. So when it's 0, 0, 0, you'll go to 6. When it's 5, you'll stay at this one. This is where our 8 inputs are coming about. The 8 bits are coming about. So when it's 1, this is how it works like. And for this, the input will be 3 down to 5, because yeah. So as I was saying, the inputs for us will be L01, L1, L2, L3, and A, B, C, D, E, F. Sorry. So this is where we have assigned the A will be output for 5, B will be output for 4, C, and so on and carry on. Then for 7 segment, it's here we have used input as standard logic vector and standard logic. For signal output also we use this same thing. So this is where it is from 6. It's for the 7 segment where we have used our lab sheets to take reference from. And then to our where's the waveform? To just show our waveform, we have used this is for the 7 segment LED. So when it's 0, 0, 0, A, B, and G, we have used this as a cross reference to help us know what is going on. So this is for the 7 segment, and then this is for the BCD, where we have given a clock impulse of 0.5 for every this one, so it's up and down 0.5 microseconds. The reset will be until to 0.5, until to the first part where the clock has gone to up, it will be all the way high. So output sensor and input sensor we have given until 6, so that it can create 5 for that can give us a nice countdown value of 6, 5, 4, 3, 2, 1. Then you'll go back to, it will start increasing 1, 2, 3, and 4. So and then for the car park LED, this will be the one, because 0, 0, 0, we have used these all we have used depending on our code, but we didn't have enough time to figure out what was wrong. As my groupmate said, we had some issues with the code, but we didn't have enough time to think about what was going on. So yeah, that's all. Thank you, Jeff.